Yeah.
We only did one problem.
Yeah.
I'll probably find one eventually.
Yeah. And when you do, please
I
ask.
feel like I need to come to you for help.
Yes. Um,
I didn't do anything.
all right, guys. We're going to finish up the note sheets today. So this is where we actually left off yesterday. So we got through all of those. All right, guys. So the first thing we're looking at is this one here, the list of prime numbers. So writing a subset of the prime whole numbers. Now, whole numbers are counting numbers 0 and greater. Almost the last one. Not all of those.
Is that our
Paper. Yep. Mm-hmm.
So if I don't, can I ask for help if I don't understand?
Yeah. Do it all on your own.
There's some pictures of like.
Now, looking at this, so whole numbers are our counting numbers in 0. So 0, 1, 2, 3 going up. And prime numbers are numbers that are only divisible by 1 and itself. So the first prime number that we have is 2. Then 3, 5, 7, 11, 13, 17, continuing on. Now, as we see these here, there's not a set. There's not a set pattern for these here. And if you were able to identify a set pattern and able to prove it, you'd actually get $1 million. Yeah. Because I'll pull it up later, but there is what they call a Millennium Prize for proving how to actually identify prime numbers and massively big prime numbers and finding the equation and proof for showing that they do exist or be able to identify them. And if you're able to prove it, you do get $1 million. No one's proved it yet. There's
Like look up on the internet how to prove this.
They've been trying to prove it for years. The kind of a formula for finding prime numbers, and the prime numbers that they're looking at are trying to prove. I think they did it up to 100 million or something like that. Found prime numbers all the way up to there, or actually it's probably even bigger. But they need it. It's more finding a systematic way to prove it and find it. There's 10 of those puzzle or prizes. One has been actually awarded out of the 10. One's been able to be proved, scientific or mathematically proven. And as he said, he really used some of the previous people's work and what they did and expanded on and was able to prove it. And he did it for the pure sake of proving it and didn't take the money. So he actually turned down $1 million. So for this here, kind of with that tangent, there's no way that we can just systematically write this here like we did yesterday for all the values greater than 50, where we can just say x is greater than 50. Here, we're going to start off with this here, brace x bar. And what is it? X is a prime whole number. That's it. That's all it is. Yeah, some of these, it's just as simple as this. Where like the last one, for the set of integers, we can do a little bit more to it. Questions on any of these here so far? Because like this one here, if we wanted to write it in set builder notation, we can say x is an element of the integers such that negative 100 is less than x is less than 100. It's technically set builder notation. We did it a little bit simpler. We just didn't include this part. We just included the other. So integers is saying we're not including rational, so fractional, decimal, irrational numbers if we don't include that, because just purely this, realistically, is just talking about all numbers between those. Now we're going to go back to the front of this note sheet. And this is what we're going to wrap up with today. So the last thing we're doing is graphing these here. So sketch the graph of each number line. This is the only graphing that we'll do. We're not going to actually graph functions. I'm not going to make you graph functions themselves. These graphs are not bad. All right, guys. Let's focus up here. Let's focus up here. So what we're doing, and this, you will do a few of these on the homework. This is the most graphing we'll do in here. Yes. Yeah. No. Yeah. The assignment is homework. The homework is the assignment.
Oh, so we can't do it in here.
You can.
If you don't
Get it done.
In the class. Why is he saying that? You said that at the beginning of the class. Oh.
Yeah. Now, what we're going to look at this here is graphing these. Now, exactly, because the first one is the set of all real numbers x such that 2 is less than x is less than or equal to 5. This is bounded because we have 2 endpoints and is everything in the middle. Now, our 2 spots are at 2 and 5. Now we need to determine which one is open and which one is closed. Yes. It might be helpful. So here, the 2 symbols are inequality symbols to determine whether it's open or closed. So if it is just greater than or less than, it's going to be open. If it's greater than or equal to or less than or equal to, we have this equal sign, then it is closed. So since 2 does not have the equal sign with it, it is open. But since the 5 does, it is closed. Now we need to shade. It's in between. And the main way I remember this here is because we have one statement and x is in the middle, we shade in the middle. When x is in the middle, we shade in the middle. So the first x is defining the number types. What kind of numbers are we talking about? So we're saying the set of all real numbers such that then it describes for especially inequalities, yes, probably. Because if we said the set of integers and we were going to graph it, so it'd be here, 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 here. Because the integers does not contain any of the numbers between 2 and 3, because those are fractional, decimal, rational, irrational. All of those are not included in the integers. So we only look at those points. But for all the ones we'll do in here, we're not going to talk about integers, whole numbers, natural. We're going to talk about real numbers. We're going to talk about all those between them. So we just have that there.
So that will never change.
Now, especially for graphing on a number line. So let's look at the next one here. So the set of all real numbers x such that, let's focus up here, x is less than or equal to 0 or x is greater than 4. So our 2 main points are at Khalil Focus up here. So we have 0 and 4. So we put those two circles on a number line to signify those 2 points. We need to determine which one's going to be open, which one's closed, or both open or both closed. So at 0, 0 means it is, closed is equal to, open is not. So if we look at the first part, x is less than or equal to.
So 0 is closed. 4 is open.
Because it is just greater than. So here we have 2 separate statements, yes? So let's look at each one individually. For the first one, less than 0. So at 0, are we going to shade to the left of it or to the right? Left, because those are all the points that are less than. Now the other one, x is greater than 4, so we would go to the. Yeah. And the biggest thing I would say for everything we do in here for Algebra 2, do not try to do everything all at once. Focus on the steps, because we're going to be taking them each individually step by step. And if you focus on the steps and doing the steps, it's going to be easier than just trying to tackle the whole thing. So we're going to learn them part by part, step by step, and just keep those steps. I didn't know you could fit 6. Let's look at the next one, C. Sketch the graph of this here. The set of all real numbers x such that x is less than -2 or x is greater than 0. So our 2 key spots are -2 and 0. So neither one of them is shaded because we don't have an equals on either one.
0 shading to the, they're both shading to the right or left.
So x is greater than 0, yes?
Yeah.
So right or left?
So it's right.
So it is right. Mm-hmm. And that's it. And for this here, really graphing these inequalities is stuff y'all done. Y'all did those in Algebra 1. The only thing we really added is set builder notation for this. Now for the homework assignment, because you're going to be doing them on a sheet of paper, these are kind of how you would do it. Because I'm not expecting you to draw a whole number line, do 0 and number it out and make sure it's completely uniform and it's to scale. So let's look at the first one here. So it's at the bottom of that one page. So number 4. So, yeah, so our 2 main points are -6 and -2, yes? We have -6 and? So, yes, some math teachers I've had and I know would want you to put 0 in relation to how this is set up. I'm not making you put a 0, making you make sure they space properly. We know that we have these 2 points. We have -6 and -2. Those are key points. And we'll have a circle at -6 and -2. -2 would be close because it has the equal to.
I think I got it right here. Look.
And x is where? Between them, so we're going to shade between. Because if we look at the 2 statements, -6 is less than x, which is telling us that all the values of x should be greater than -6.
So if there's an x right there,
If there's an x between the 2, we shade between them.
So we don't do the advanced, the word or.
If we have the or, look at it part by part.
If there's or, it goes.
It normally goes in 2 directions, but I would still look at it in individual parts because it could be that they're set up so that they go at each other. And if they go at each other, it's going to be the whole thing. So But it is, if it is one statement, like 4 is, we're going to be shading in the middle. Because if x is in the middle, we shade in the middle. Let's look at number 5 last. For all real values of x, x is less than or equal to 0, or x is greater than 10. And the only thing I ask when you do set them up this way is that they are set up properly. Smaller number on the left, bigger number on the right. That they actually do go according to how a number line should look. We don't have them flipped. We're in the wrong order. Indeed, they would both be shaded.
They're both going off of the out.
Yes.
That was why I'm ready to go.
If we only have one, we're going to shade this one direction.
Are we done with that?
And we are done. We're not going to do the rest. I threw those out.
We only have 1, 2, 3, 4.
Five, 6, 7, 8, 9, 10, 11, 12, 15. No.
1,
Yeah.
2, 3, 4, 5.
Yeah. Yeah, so it's 20. Now, for the first part,
We don't have time to do this tomorrow either.
so y'all can go on and get started now. I will help you. I can come around and help you. Answer questions.